Okay, thank you very much. Thank you for the very nice introduction. And my name is Kwon Park. I'm from KIAS. And today I'd like to talk about languages of two words, people versus quantum. And I'd like to talk about my personal journey to becoming a translator between the two words. So when I give a talk to the public, I often get the following questions, which is it possible to understand quantum mechanics without using mathematics? Short answer is probably no, right? So I can explain this in many different ways, but I'd like to explain today in a fun way, which is to quote movie. In fact, as a side story, I really wanted to become a movie critic when I was in high school. So I was really debating myself whether to become a physicist or the movie critic. And finally, it seems that I like the physics more, right? So I'd like to talk about movie. So this movie is one of my favorite movies. And there's a reason why I talk about this movie. And this movie is called The Arrival, which was made 2016 by Denis Villeneuve. Actually, he directed also Dune series, actually. So in this movie, basically this movie is based on a novel written by Ted Chiang. So here there is this kind of weird shape, which is actually a spaceship. So 12 spaceships arrived at the Earth someday. And then people try to understand the reason why they visited us, right? So all around the world, 12 ships arrived, as I said, and in the state, they form a team of two people. This is Amy Adams, played by Amy Adams, and she is a linguist, so that she can understand what the space alien are talking about, right? And also she's teamed with a physicist whose name is Ian. So this team of two try to approach the aliens. Actually, if you saw the movie, you will understand how difficult that conversation can be. Actually, I show you the scene. This is actually aliens. This very scary looking these two creatures are aliens, and they have 7 limbs, and they like in some sense like octopus or something, and they approach to the some kind of a screen, and Louise in front of these aliens, and they're trying to she is trying to understand what they're saying, but it's very, very difficult. It's completely different language system. So she realized that actually it's better to understand written language than spoken language, right? So she tried to understand what they're trying to write. Actually, surprisingly, this kind of circular figure in the air is their language system, written language system of space aliens. So in fact, they extend one limb into the air, and they shoot out some kind of ink into the air. And that ink spread into the air and forms some kind of pattern. And Louis realized that there's something strange going on, because when the alien starts writing some message, and the ink is spread seemingly random way, but at the end of the circle, it just kind of matches with the end part, so that they form a kind of meaning in that way. So in other words, aliens kind of can foresee the future. So alien speaks in such a way that he sees all possible futures at the same time. So according to this the movie and the novel as well, there's a reason why alien speaks this way, write this way, because alien thinks under the principle of quantum mechanics, right? So that since they are thinking that way, they speak that way. So they see all the possible futures. Actually, there's a side effect. During the movies, Louis is beginning to understand the alien language. And so she also got the ability to see the future, to see the all possible outcomes of the future. So one side effect that she has this kind of vision that her daughter is dying out of terminal illness. But of course, she's not married. And she, of course, she doesn't have a daughter right now. But this is the future. So she sees the all possible future, and that she can see as this as a part of the future, because she gained the ability of brain working quantum mechanically. So what I'm trying to say is that there are many messages of this movie, but what I'm trying to say is that understanding quantum mechanics is as hard as understanding languages of space aliens, right? So, but if you understand the languages of space alien or quantum mechanics, you can see the future, all possible outcomes, right? So that's the message that I'd like to convey. So actually, I'd like to focus on very specific concept. As a physicist, I'd like to talk about very specific example. So everybody is saying quantum mechanics is very hard. It is hard. And there are many complicated concepts that you have to understand in quantum mechanics. That in this talk, I'd like to single out one particular concept which people talk about a lot, which is superposition, right? So what is superposition, right? So one can explain the superposition in many different ways as well. And this is a usual kind of fable, Schrödinger's cat. And actually this cartoon is taken from my article, which I wrote in the webzine called Horizon. So as you know very well, so Schrödinger cats, on the left-hand side, cat is alive, maybe happy, I don't know. The face, her expression is kind of weird. But the cat is alive because the bottle with the toxic gas is not broken yet. But that's connected to the glass box where the atom is in excited state, so there is no photon. So the hammer is not activated, so that the cat is happy and alive. But on the right-hand side, the cat is dead because the hammer was activated because of the atom transient made a transition to the ground state. So this is what everybody explains, right? But as a physicist, I always have a kind of unsatisfaction in some sense, because so what's the deal with this analogy, right? So more specifically, what's the meaning of adding live cat and dead cat? What do you mean by that, right? What's the real meaning of that? Is it zombie, living dead, right? So again, I like movies, right, as I said, right? So this movie is one of my favorites as well, 28 Days Later, which was directed by Danny Boyle, the English director, in 2002. So where the main character just woke up one day, 28 days later, and then the world has collapsed, completely collapsed, because most of people just got infected by this dangerous infectious virus, so everybody become zombies, right? So this Schrödinger cat, is it zombie? We all know that it's not, right? Because zombie is something else. It's not living or dead, right? But this superposition is that it's both in some sense, right? When you observe the Schrödinger cat, sometimes it's alive, sometimes it's dead, right? So as a physicist, whenever I explain this, it's very difficult to explain what this is, actually. In fact, this problem has become more crucial and becoming more and more crucial because of this advance of quantum computers, right? So people talk about qubits, right? I was told don't talk about qubits, right? Because people explain what bit is. But basically, qubits is superposed state between 0 and 1. So what do you get if you add 0 and 1? you get obviously 1, right? Right? But that's not the case, right? So if you add between 0 and 1, what would you get? Right? So this is the, I guess, most technical slide of my talk today. So qubits are the superposition of 0 and 1. So usually people picture, like visualize this as kind of arrow or spin, right? So that on this sphere, so there is this North Pole, which corresponds to 0, and which also corresponds to arrow pointing that direction, right? And 1, which is actually South Pole, and arrow pointing that direction. Again, I can ask a question. If you add pointing North Pole, pointing South Pole, what do you get? You get 0, right? If you think this is a vector. But that's not the case, because qubits are represented in terms of this arrow, but qubits are not living in actual vector space. It's something else. So for example, people usually talk about the advantage of a qubit is that you can store much more information into just into one qubit, because you can have infinite way of linearly superposing these two states, right? So that one qubit can store many more information than single bit, right? But again, what do you mean by this superposition? Is it zombie? No, it's not, right? So of course, I don't have time to go into details of how to explain all these things, because I don't have time, right? So I begin to embark to explaining to this to public, and I was having a hard time, because quantum mechanics is based on a framework of linear algebra within the so-called Hilbert space, not the real space, Hilbert space, where the world exists in an abstract form, fundamentally abstract form. So I think quantum mechanics is fundamentally hard, because you have to embrace the idea that worlds actually exist in some abstract form, not the real space, right? So I'd like to talk about some of my attempts to convey this idea in everyday language. And so actually there is a foundation called Chaos Foundation in Korea. And I made 6 videos explaining all the quantum mechanics from the bottom up, from the calculus, all the way from calculus to all the way to quantum entanglement. So I'm not sure I was able to, I was successful in conveying this idea, but I was, personally, I thought it was very important to make people understand the essence of mathematics. Without mathematics, it's all very superficial in some sense, right? So I was trying my best, and also the couple of weeks ago, I had a documentary, EBS documentary. EBS is an education broadcasting system, which corresponds to like PBS in the state. So I was kind of presenter and actor in this documentary series, and the title is A Strange Day of a Physicist. So this is a like trailer.
안녕하세요.
And
이로 물리학자 박권입니다.
that's me.
여러분은 물리학이
So here,
무엇이라고
this documentary is composed of 3 parts, and the first one, this documentary talks about time. So first episode is the classical time. The second episode, relativistic time, and third episode is
무게중심이
quantum
잡히지
time.
않은 물체는 바닥으로 넘어집니다.
So here, I cannot, of course,
이것이
explain
우리가 지금까지
all the details
배운
about
시간의 흐름입니다.
mathematics, but I try my best
그런데
to
정말로 우리의 삶은
expose
확률이 높은 방향으로만 흐르는
how
것일까요?
the quantum world is so fascinating. Okay, so I am already at the end of my talk, actually. So what's my conclusion, right? was I successful in delivering all this idea to public, or was I able to explain all these complicated mathematics to the public? Probably not, right? But this is, as mentioned earlier, this is not sprint. This is marathon, right? So we have to we have to have a long vision, long-term view of how we can achieve this, and so that my journey continues. And hopefully, we as physicists, we were also people before, right? Who didn't know about languages of space alien, right? But now we believe that we understand the language of space alien, right? So this, the obstacle from quantum awareness and quantum education, that can be bridged somehow, I hope. And thank you very much.
Okay.